Hello and welcome up to my YouTube channel Java Stories, and today we are going to look into some of the important things on the reduce operation in the JavaStream APIs. Most of the time we do not use this reduce operation much because we are able to do a lot with the collectors API only, but sometime if we have to do something out of the box and if we know this reduce operation, then there is a possibility that we would be able to do those kind of stuff. Otherwise it will be difficult to do it. Now let's get started and we will look into some important tips on this reduce operation. Suppose we have this list of integers and we need to sum it with the help of the reduce operation. Of course, reduce operation is a terminal operation. As soon as we do the reduce operation, the stream would evaluate. So how we could do the sum of this list is quite easy. Integers dot stream, we open a stream on it, and then we have to use this reduce operation, and this reduce operation takes a binary operator, and we say we need to add this a and b, and we simply say a plus b, and if we check the result of this, let's see this, you could see that we receive an optional. And why optional? Because if the list is empty, then the sum cannot be even 0. It has to be an optional. It is basically undefined. The sum is undefined, so the Java wraps it in the optional and the optional is empty. This can become a pain. You have to every time check this if the option is empty or not. So to get rid of this kind of a stuff in a mathematical operation, what we could do, there is another way of doing this. We will look into this. If we provide an identity element, which is the first parameter of this reduce operation, and then we provide this binary operator, if we look now, then we could see that yes, now the sum is integer itself and not an optional, because even if this list is empty now, because the identity element is present, it will return a 0. But we have to precisely look into what is an identity element in a mathematical operation. This is some kind of a mathematical stuff and we will look into this now. Suppose I represent this identity element with E, and if I do any operation, consider this symbol as a mathematical operation, and this is an operand, any number basically, and if it is written operand itself, then I would say E is an identity element. For example, in the sum, suppose we have an operand 5, and if I just sum it with 0, it will always return 5. So we would say for the sum, E is an identity element. Suppose for the subtraction also, any element, this is an operand, you subtract it by 0, it will return the operand itself. Even if it is minus 5, you put 0, it will be minus 5 only. So I would say 0 is an identity element even for the subtraction. But what about the multiplication? For the multiply, suppose there is a number 5, you have to do something. I do multiply by 1, then it will be 5. So here the 0 is not the identity element, 1 is the identity element. So you got the gist now, but I will just let you know some few more identity elements of some famous operations. Suppose we have to do a max operation, a number 5. If I do a max operation of number 5 with minus infinity, it will always be 5. So for the maximum operation, the identity element is this, infinity, minus infinity, and same goes for the minimum. If I have to find the minimum, Suppose I have to find minimum of suppose 10 lakhs. It has to be, if I find any minimum with the infinity, it will always be the number itself. So this is an identity element for the minimum operation. And if I talk about the string concatenation, then you could say if ABC is the string, if I concat with the empty string, it will always give me an ABC. Then I could say that okay, the empty string is the identity element. Hope you got the gist here. Now if I just print the reduced one, it will give me an answer, which is 6. Even the list is empty, and if I again go with this, the answer is 0 because we have provided the identity element. Here if I just print out the reduce, it will be an empty optional. See, this optional is empty. Now we look into this binary operator. It's a very simple. A plus B, we just say, you just do an addition of A plus B and then fed the result of this A plus B in the first element of A and take the next element from the B. This way basically the things happens behind the scene in the reduce operation. But now there is also one caveat we need to understand the reduce operation, and this is the second point which we need to consider while we do reduce operation, and we will see precisely in the second tip is that the operation should be associativity. It should be associative, I would say. So what is associative? Suppose we performing an operation A operation B operation C. This is if this equals to this is an associative law in the mathematics. If any operation follow this, then you could perform the reduce operation. If it is not an associative operation, then make sure that you never use the reduce operation, because you will not get any syntax errors. You will get a result and you believe that you are getting a result without any error, but the result is wrong. For example, the sum, if we consider the sum 1 plus 2 plus 3 is always equals to, if we add 2 plus 3 first and then add 1. So sum is an associative. If you talk about the multiply is also associativity. It's follow an associative rule. 1 into 2 into 3 is equals to 1 into 2 and then multiply by 3. But if you talk about the average, if you have to take the average, then there is a problem. If you have to take the average of 1 plus 3, you cannot say average of 1 plus 2 and average of 2 plus 3. Oh sorry, I would say average of 1 plus 2 you take first, and the result you take the average of 3 and then you take the average. It will not give you the same result, right? So this we need to take care about in the reduce operation. If I have to get the average of 1, 2 and 3, let me just get rid of this. If I say, because average of two numbers is a plus b divided by 2, and if I now check the answer, reduce 1, here the answer is 2, but if you take a 1 plus 2 is 3, 3 plus 3 is 6, 6 divided by 3 is 2. Oh sorry, 6 divided by 3 is 2. Now you could see, okay, suddenly you are able to see this reduce operation is working, this average is working fine with the reduce operation. But what if I just add another number and then let's check what the result is. The result is 3, and if I just calculate now, 4 plus 3 is 7, plus 2 9, plus 1 10, 10 divided by 4 is somewhere around 2.5 only. So the average is not working, but suddenly you would see you are getting the result, and if it is a long list of numbers and you forget to identify this rule of mathematics, the associative rule, then you may find yourself in some kind of a trouble. So if you keep in mind all these 2 points, then I think you will be able to do something nice about the reduce operation when the situation really commands. I hope you like the video. If you like this video, please subscribe, please like the video, and also please share this video to your Java friends who love all this kind of stuff to do in the Java. Thank you so much.